This is blood flow. We're going to start off with the heart. We know the heart does not really look like this, so I'm going to draw a box to give us a better depiction of where the blood is going. On the upper part of the heart is your atrium. On the lower part of the heart is the ventricle. Then you have your right side. We'll put an R for right. Then you have your left side, put L. There's a valve here called a tricuspid valve. We'll put a T. There's another valve here called a bicuspid valve or mitral valve. We'll put a B for bicuspid. Here we're going to draw the vena cava. The vena cava is just another way of saying large vein. In here, deoxygenated blood is going into the right atrium. Once it's in the right atrium, it's going to pass through the tricuspid valve, which is a one-way door so that blood doesn't go back the opposite way. It goes into the right ventricle. Behind this heart, if I was able to pick it up and turn it around, behind here is another valve that's taking blood through a pulmonary artery away from the heart to one of the lungs. It could be also taking the blood to this lung as well, which only has 2 lobes. This lung has 3 lobes. This is the pulmonary artery because it takes blood away from the heart. P-A. Here, there is an alveoli. There are many of them. And the capillary is going to run around the alveoli, or excuse me, the pulmonary artery is going to become really, really small, and it becomes a small capillary, and it's going to run around the alveoli until they share a wall. Here, this alveoli has lots of oxygen in it because the person just inhaled. So their lungs are full of oxygen. This blood, remember, is full of carbon dioxide. Carbon dioxide. It needs to leave the body. So here, carbon dioxide is dropped off, oxygen is picked up, and it goes back to the heart. Since it's going back, it's using a pulmonary vein. And it'll go back to the heart, and this time it won't be on the right side. This time it's going to be on the left side because blood has to be pumped to the body now. So all this oxygenated blood is pumped to the left side through the left atrium first, then past the bicuspid valve so that blood doesn't go the wrong way. This door closes and the left ventricle is full of blood. Here is where systolic pressure is created. Also, there's a lot of muscle in the ventricles. The ventricles are responsible for the myocardia, the muscle here is responsible for the contraction. So, here, we're going to draw the aorta. There's 2 aortas, one going up to the head, one going down. Therefore, it's an ascending aorta and descending aorta. For now, we're just going to draw the descending aorta to make things simple. And as the aorta continues on, it becomes smaller until it becomes an artery. Remember, there's oxygenated rich blood in here. Oxygenated blood. This is an aorta. Remember, all A's go away, artery, because it's getting smaller. And as it gets really small, it becomes an arteriole. Then it meets cells at the capillary bed, where they drop off oxygen, the blood cells, the red blood cells I mean, drops off oxygen and picks up CO2. CO2 is the waste that the nearby cells made when they were making ATP. Cell made ATP plus CO2 plus water. This has to leave. So it leaves when the blood passes through a capillary, drops off oxygen, picks up the CO2, kind of like a metro bus stop. But it has to leave now. And the only vessel or only highway is going to take it back to the heart is a vein or venule. All these come to meet. Then it gets bigger, which now is called a vein. Then as it gets bigger, it hooks up with this big vena cava we just made. This vena cava right here. Remember, this is full of CO2 plus CO2. So the CO2 rich blood or deoxygenated blood comes back into the same cycle, right atrium, past the tricuspid valve into the right ventricle, leaves the heart going through a pulmonary artery to an alveoli where CO2 is dropped off, oxygen is picked up, goes back using a pulmonary vein to the heart, this time is on the left side, through the left atrium, past the bicuspid valve into the left ventricle, then it leaves going through the ascending or descending aorta, but this blood is oxygen rich because it just came from the lungs, and it goes down to a smaller tunnel, which is now called an artery, and now the artery becomes even smaller, now it's called an arteriole, and now it meets the capillary bed and does the same thing again. Drops off oxygen, picks up CO2, leaves, goes back around, kind of like the Beltway 495, and you can only drive on one way. Same thing. So it starts our cycle over and over and over again. Systolic pressure is created here. Remember that? Remember that? So there's high pressure in arteries and aortas. High pressure. There's low pressure here. And if you can get a visualization that if you have high pressure here, it would drive things here to a lower pressure. Make sense? You have high pressure here, all this pressure is going to want to go somewhere. It's not going to stay there. So it's going to drive this way, continuing this circle. Okay. So that's why we have 120 over 80. This is systolic over diastolic. If you can get a rough idea what that means, and this is really rough, we can say that it's a comparison of what's happening in this aorta, in this vessel, which has high pressure, systolic, compared to what's happening in the other vessels, which are the veins, which has low pressure, the lower number, to make this cycle continue on. So if this number starts to match this number, you can't rotate this way if there's high pressure here. It has to remain low pressure. And that's why high blood pressure is good. That's blood flow. Hope it makes sense. After looking at it, it looks like a big mess. This is heart muscle. This is myocardia. Myocardium. Other words, heart muscle.